Hello everyone. Today we'll talk about citizen environmental monitoring and especially about our monitoring system. I know that many of you already are making observations and registering the results on our portal, but first some reminder of basic monitoring system rules of participation. Then we'll talk about abiotic observations and rules, how to be observer, how to be a scientist, and then some more about phenology. We'll end with a code quiz, and if we also have time, we'll show you live online how to fill in our forms and how to submit observations. So, as for basic rules of participation, you know that teachers report, right? But this students, you are the ones who are supposed to provide data. That is, what is going on in your surroundings, what is that you observe during your everyday life or during your weekend walk. What is important is that you should report on regular basis, not only because it allows you to gain points in our EDU-game, because you gain 50 points for registration and then 10 points for weekly for regular active participation in our program, but also because it allows us to create a series of measurements and observations. And also it allows you to create some sort of scientist routine for maybe which will be useful in your future scientific career. You should report on Monday, Tuesday by the latest, but only with Monday data. As for actual values, we'll talk about actual values and other types of data in a minute.
Dobra, już wiem.
Actual values should be reported
Już wiem, poczekaj.
in local time. Remember that I know that in some cases each school has several engaged teachers with their classes, with their teams. One report from one location school per week is allowed. If you want to engage more classes, more teachers in your system from the same school, you should maybe create an internal schedule like everyone's reporting every 2 weeks. What is important also, we chose biotic elements that might not be actually possible to observe or present in every country, in every surrounding. If something is not observed, if some species is not observed in your surroundings, please leave the box empty, but report all the other parameters. Like I said, it's worth it also because you gain points, extra points in EDU-game. How to start? I know that many of you are already engaged, but it is really easy to start. Your full location, that is you mark your location and then your coordinates appear, and then press submit, which also doesn't take much time. Then we'll show you the section on our portal, hopefully, when you can. First of all, you can find there our monitoring manual. Now it's in English and in Polish, describing all the parameters and many other things too. This is what you see. This is a display of coordinates of your school. But you only give it once in the beginning when you sign in for the system. What it is displayed, what the results are displayed like, is differs from what you fill in, because you fill in a sort of chart. Then you choose actual values or other data from a list. It looks like that, and we'll show it online also. And all your measurements are gathered in one place. You can check them in your profile, My Measurement section. You can view all that you already registered and submitted. And also, which is very important, this is an actual result of your reporting, a map that is displayed on a portal in monitoring system section, This allows to show and to compare data from almost whole Europe, and we also have one school from Colombia, so we have different continents as well. You can observe the map by choosing different types of parameters. You receive sort of different layers of the map. Also, you can get the report in XLS format that allows you to observe, for example, variability of parameters. So thank you, and now from the meteorologist point of view.
Welcome everyone. My name is Tomasz. Sorry. So from the beginning of this monitoring system, we were thinking what should we register, what data, and we decided it has to be for free, no costs at all. So everything you can observe without paying for anything, without using any instrument. Actually, the only instrument you will use will be thermometer. What's the reason to observe weather and environment? It doesn't matter where you live in the world. We have schools from different countries, all around Europe actually. And it doesn't matter where you register. When you give your location, when you get the information about the weather, you know that most of your activities are closely linked to the weather, because all our life is dependent on it. Weather and climate are both natural resources and hazards. They support, but it can also pose a threat to life, property, and the environment. So all the meteorological and related environmental observations are used for the preparation of weather forecasts, severe weather warnings, for local weather-dependent operations, for example, at airports, because takeoff and landing is really dependent on the weather for airplanes. This data is also used for hydrology, for food production, and also for research in meteorology and climatology. The thing is, the weather systems move across country boundaries. There is no boundary for the weather. Weather doesn't know the boundaries of countries. So in 19th century, some organization was founded. It was called International Meteorological Organization, and it was formed with the purpose of exchanging weather information among different countries, because everyone knew it's really important to know what's going on around us, and having those data gave us possibilities to predict weather in our country, for example. This organization became World Meteorological Organization on 23rd of March 1950. Its main purpose was standardization of meteo and related observations. Now, WMO has 191 member countries and territories, 11,000 land stations, 3,000 aircraft, 400 ships, and 2,500 buoys at sea. So that's the network of observations made by special instruments and specialists, meteorologists, and they collect data and send those data to WMO centers, where maps and charts are created and where the forecasts are prepared. But you don't have to be specialist. As a citizen, you can use your eyes and also report and check on our website in our monitoring program what's going on around us. Meteorologists around the world acquire and process and interpret data from instruments on land, sea, and sky and space. You can see different stations on sea and on land. Different satellites are used, and it's really expensive, and it's hard to collect all the data, but the monitoring we suggest can be done by students. It's not that complicated. Weather forecasting how to forecast the weather. First, you have to acquire present weather data, and it has to be done punctually. That's why we want you to collect data on Mondays at 12. Then, graphical depiction of the state of the atmosphere. When you will put your data, it will be published online so everyone can see what's going on in your surroundings. Then you can analyze the data and maps, and then you can think about predictions of future state of the atmosphere. But we won't do any predictions because we would need really expensive computers and stuff. So we will just think what's going on in different parts of Europe, having all your reports. Then when you have all this data, you can report the weather information to the public, and that's something that we will do, of course. The purpose of our monitoring was giving advice on practices for some meteo measurements and environmental observations. So even though you're not specialists in meteo observations, you can collect the data, and we hope it will be really interesting, as it is for us, to compare the data from different places, so whole network of observations. And we hope you will enjoy collecting the data and seeing what's going on around you and seeing what's collected in different places. What are the parameters that are observed and reported? So we divided those into actual values and also values that you collect from previous week. And then we divided those into abiotic and biotic environments. So something that you send on Mondays at 12 a.m., so at noon, midday, first thing to collect is air temperature. So for that, you actually need thermometer, but actually maybe you can also use something that you have, like your smartphone, just to check the local weather at 12. If you have thermometer, you have to remember that it shouldn't be put nowhere else but in the shade. It has to be in the shade because this gives you actual air temperature in good place, because the sun would warm the instrument that you have. So you want it to be in shade. So when you have thermometer, just put it outside the window on the north side. For example, at your school or in the house. Another parameter is cloud cover. So here you just type if it's clear sky, so no clouds at all. The sky can be partly cloudy, so when you can see some clear sky between the clouds, you just type partly cloudy. And complete cloud cover. So it means that you cannot see clear skies. The whole sky is covered by a layer of clouds or layers of clouds. Atmospheric precipitation. What you report is no precipitation if it's not raining, snowing, or whatever. You should report also showers, because that's something different than continuous precipitation. Showers begin and end suddenly. They live shortly, may last half an hour or less, and often, but not always, are separated by blue sky. Showers usually come from puffy clouds or cumuliform clouds, like cumulus or cumulonimbus. So when you can see those puffs on the sky, you can maybe expect some showers. Continuous precipitation, it doesn't cease after half an hour, or ceases only briefly, and leaves many hours or even days. You will know when it's continuously raining, that's for sure. Then we choose the type of atmospheric precipitation. We have different types of precipitation. First, you can report drizzle, so the fairly uniform precipitation composed exclusively on very small droplets, less than 0.5 millimeters. Then you can report rain, so bigger drops, snow, easy to distinguish. Hoar-frost. Hoar-frost is coating or deposit of ice that may form in humid air in cold conditions. So when the temperature is below 0 degrees, usually it appears overnight. And hail. Hail is another form of solid precipitation. It consists of balls. So these balls usually fall when there's storm. So cumulonimbus clouds produce these kind of precipitation. Then you have to report visibility reduction. So when there's good visibility, more than 10 kilometers, you just type none. In misty conditions, so between, mist restricts visibility to between 1 to 10 kilometers. Also fog can appear. Fog restricts visibility to less than 1 kilometer. And there's also smog, which is smoke and other forms of atmospheric pollutants that have an important part in causing the fog to thicken. Usually you will hear about it in the media then smog appeared. It happened many times this winter in Poland, in Warsaw and big cities. Another thing to report is wind force. Here you just type no wind when there's calm conditions. Smoke from chimneys rises vertically. Light wind means that there's weak wind that lightly moves leaves on trees. Gusty wind moves branches on the trees, sways small trees and leaves. Dust and loose paper can erase. Hurricane, strong wind that causes damage to nature and households. When there will be hurricane, for sure you will see it. It will be strong wind, and after some time in the media, there should be some information that it will cause some damage. So that's something that you also report when on Monday hurricane appears. And other parameters are noticed since the last observation. So 1 week after previous observation, so previous Monday, and that's the information that you collect throughout the week. So it means from Monday till next Monday, you just go outside, you can go and see what's going on rivers, what's going on lakes, when you have any in your surroundings. You just have to observe snow cover, it appears, what's going on with it, but some more information on next slide. First thing to report is lightning. So when there was no storm, no lightning, you just type none. Lightning inside clouds. So when you heard lightnings, but it happened completely inside the clouds, so or was jumping between different charge regions in the clouds or in the one cloud. And you have to also report, just type the last one, lightning strikes the ground. So it occurs between the cloud and the ground. Usually when you see this kind of clouds, cumulonimbus, they form thunderstorms, so you can expect some lightning. So you should observe them, but from the safe place, like inside home. Don't go too close to the window because it can be dangerous sometimes. Snow cover. So you just type if there's no snow cover during summer, I guess in whole locations it will be the same, non-snow cover. But once it appears after summer, you just type first snow, and you just type it once in a year. So the first snow happens, it can happen in September, October, or whatever month. You just choose it, and then it stays grayish. So we are interested when the first snow appeared after summer. Then you can choose snow accumulation when you observed the snowfall in previous 7 days, and you observe the increase of snow cover thickness. So just compare it to the observation in previous week. So if there was some snow accumulation, there should be more snow on the ground. If there was no snowfall, but there was snow noted on the ground in the previous observation, and nothing happened to the snow cover, it just stabilized, it remained there, but consolidated. So temperatures were below 0 degrees. You just type stable snow cover. When you see decline of snow, you can see the surface runoff produced from melting snow. You should type snow melting. Ice on lakes. When you have a possibility to go in the surroundings in your city or close to your city, if there's any lake, you should observe it. If there is no ice on the surface of lake, you just type none. When the temperatures drop below 0, you would see the freezing of the lake surface, so just type freezing. It can freeze completely, so the whole surface of the lake can be frozen. It usually happens during winter when the temperatures are below -10 for some time. Then you just type complete ice cover. After that, when the temperatures rise, you just type lake surface is melting, because you will see some water on the top of the lake, and you will see the disappearance of ice cover. Ice on rivers. That's also easy. There can be no ice at all. It can be partly covered by ice. So if you see the river banks covered by some ice, you just type partly covered. When the surface of river is completely covered by ice, you just type complete ice cover. Then you should also report extreme atmospheric phenomena. This can be interesting. So for example, flood. You type flood when you see the overflow of water that submerges land, which usually is dry. So yeah, if you see some damage in the surroundings of river, if the level of river is higher than usually, and yeah, some land is flooded, you just type flood. Whirlwind. Yeah, that's the weather phenomenon in which a vertically oriented rotating column of air forms. So it moves with some dust. Just type if you saw it. In some mountainous regions, because we have schools in different places, not only flat areas, not lowlands only, but also mountains, maybe avalanches can appear. So a rapid flow of snow down a sloping surface. Other atmospheric phenomena that you maybe will be observing and you have to report is, for example, northern lights, aurora borealis, rainbow. Maybe some of you will see rainbow, and it will be raining and sun will be somewhere in the behind. And there's also a glazed frost, so ice coating that occurs when freezing rain and drizzle hit a surface which is already frozen. Other parameters are from Biotic environment, and these will be presented by Ania.
Thank you very much. In this part, we'll talk a little bit about phenology, why it is important to observe biotic environment, and what does it say about climate change, especially in relation to those observations we're just talking about weather observation. Also, we'll talk about parameters to observe and how to observe them, and some hot tips. So, phenological observations are one of the oldest areas of environmental science, environmental observation. This happens for example, Chinese do that since 1,000 years before Christ, but the longest record of observations belongs to Japanese, who observe and record a peak of cherry blossoms. So that's a really long series of observations. These two gentlemen here are, we might say, founding fathers of phenology. The one in the middle is quite well known. This is Carolus Linnaeus, who is also well known for taxonomy, etc. They both lived in 18th century, and Linnaeus systematically recorded flowering times for 18 locations in Europe, in Sweden, over many years, and his notes also recorded exact climatic conditions when flowering occurred, and that sounds familiar, right, with our monitoring system. And the other one is a British landowner, Mr. Robert Marsham, who is considered one of the creators of citizen science, because he wasn't actually a scientist, but he observed so-called indications of spring in his estate in England, and so it's observed dates of first occurrence of events such as flowering, bud burst, flight of an insect, etc. And for generations, even after his death, his family continued till the middle of 20th century. So, in the simplest terms, phenology is a study that measures timing, appearance of life cycle events in all living things, in plants and in animals. And the life cycle is not actually a period between life and death of an organism, but it's a period of time which involves a single regeneration to reproduce. Not necessarily referring to lifespan, but rather reproducing another generation. And those events that happen in life cycle are also known as phenophases, that is phenology. In plants, this is, as you can see, first leaf, bud burst, etc., etc. In animals, for example, mating, offspring production, molting, that is changing skin, also appears in some species. Hibernation, migration, for example, bird migration. And scientists who study phenology, that is phenologists, are interested in timing of these events, but in relation with seasonal change and climatic change, and they attempt to learn more about those abiotic factors we're talking about that plants and animals respond to. But how do animals and plants know when to act, where to start those events? There are three main abiotic factors that influence those processes. First of all, it is all written in their genetic code, but abiotic factors, but they are vulnerable to abiotic factors such as precipitation, sunlight, and temperature, and that's what determines when they start natural events like, I don't know, frogs and salamanders that breed and their offspring goes through metamorphosis. Flowers bloom. Birds migrate back and forth between their breeding grounds and wintering grounds. Leaves change color, butterflies go through metamorphosis, and so on. And those three factors work together, determining the timing of those events. So, and those three factors are strictly related to climate and therefore to climate change. And to discuss how climate change affects phenophases and their timing, we need to understand how it is affecting seasons. Because when we talk about global warming, we are used to the image of very, very hot summers, but actually it often surprises people that it is winter that is the most rapidly warming or changing season. It is more exactly what is happening twice as much, twice as fast. It is, and there are direct consequences of this warmer and generally shorter winter, that in the northern hemisphere, the spring is arriving earlier, approximately more than 1 day per decade. Also, land surfaces are also retaining more heat and stay warm longer, and that means that the growing season is expanding. It expanded from 1960 to 1999 by almost 11 days. 6 days earlier in the spring, almost 5 days towards in the persisting summer. And that is based on, that is not, we're not supposing that, is based on 29,000 observational data. The other thing is whether plants are able to use that warmth if there is not enough precipitation during summer, but that is something. And there are two ways of responding of phenophases. That is how species cope with or try to cope with climate change. One is space, geographical response, and the other is time, temporal response, which is closely related to phenophase. As for space, usually species go poleward, upward in elevation. That is, they go towards north in northern hemisphere, towards south in southern hemisphere, and upward more towards higher, towards mountains, we might say. But migration into new territory is not always possible because of habitat fragmentation, human or natural, because we build highways or shopping malls, but there are also natural barriers, rivers, mountain ranges, etc. So it is also very dangerous for the range of species. For example, Arctic fox, the population of Arctic fox is decreasing, partly because of red fox, which is moving northwards, is more ferocious, more aggressive, and is causing decline of population of Arctic fox. And on a temporal scale, usually phenophases happen faster, earlier than before. As you are observers, and your surrounding influences a lot the result of your observation, but not only whether you live in Greece or in Poland, but also it is important whether you live in a country area or a large city. It is called a urban heat island effect, because in modern cities the temperature is much higher than in their surrounding or in agricultural areas. And the temperature, as you can see, is the highest in downtown, in the center, and the city increases temperature in two ways. First, normally when rain falls, it would soak into soil, evaporate back to the atmosphere, carry heat with it, and it would lower the temperature. But now when water flows over paved surfaces into sewers and into infrastructure, the heat stays there. And second, those paved surfaces are like asphalt, like roofs, is basically darker in color than the natural surface, and that lowers the albedo. And that means that less sunlight energy is reflected and more stays on the surface. So you might expect that you welcome the first indicators of spring, or first open buds earlier in the city than in the rural area. As for parameters to be observed, you have all that in your manual, so I won't be talking about every single one. I just like to compare some and show you some characteristic parameters. You can see that this is how you choose, and not all the parameters are available for all the plants, for example. You can choose, for example, ribbon berries only for rowan and bilberry, and seeds ready only for rosebay willowherb. plants. Just to present them a little bit, I think we chose rather common ones, even though they might not be common, common in every country. Birch is a really easy to recognize because of its white peeling bark that looks like a tissue paper. Bilberry, I think everyone knows as this small low shrub with round leaves. It's also good to know that birch is common and can be met everywhere because it doesn't need very good conditions. But bilberry, for example, can be often met in pine woods because it needs more acidic soils. Lilac is very popular in gardens, in parks, because of its beautiful, fragrant flowers. Rosebay willow help is actually more common in the north, with its beautiful purple flowers, like Russia and Finland, but it can also be met in other countries. For example, in UK it was called the bombweed because it is the first thing to bloom in bombed London during Second World War. It chooses swamps, burnt areas, disused fields, railway embankments, etc. Also it is quite easy to recognize even without those beautiful flowers because of veins in the leaves. It is shown in the manual that they do not extend to the outer edge of the leaf, but loop near the margin. Rowan is also very characteristic because of its first green and then bright orange red fruit. Here's a list of parameters available for those plants. Like I said, not the parameters are suitable for all the plants. As for parameters, just few tips. Birch has very sticky buds. Open buds means that first leaves push out of the bud and are completely unfolded. This is how it looks like. So birch buds are very sticky and fragrant, and rowan buds have characteristic gray hair, and lilac buds actually have nothing very uncommon. And I'd like to show you that or not, if we can, because this is actually straight from yesterday. We are doing observations as well. This is not yet opened bud of birch with a flower at the same time. So sometimes it happens parallelly with a catnip. As for starting to flower, I think it's quite easy to observe. Something interesting, that birch has long yellow-brown flowers that produce yellow pollen, yellow dust, we might say. And the rest, bilberry also has very strange, we would say, flowers, white or green that look like cups. And the rest are, I think, quite easy to observe. Ripen berries and seeds ready. I think you will be able to recognize seeds ready with rosebay willow herb because they look a little bit like balm wool. Well, as for leaves coloring and falling down, I think that we can say that leaves start falling down when it's up to 10 leaves falling down, and then when they're completely fallen down, I'm not sure what's going on with our presentation. When it is because the plant is preparing for winter and is saving energy not to lose it for maintaining leaves. As for insects, we chose bumblebee, mosquito, ant, European peacock, and common brimstone. They are interesting because, for example, bumblebee is the northernmost insect of those which appear in Europe, because it is able to show thermoregulation because of shivering abdomen, and that is quite unusual among insects. And European peacock and common brimstone show different kinds of mimicry. European peacock is pretending to be a large predator because of sort of eyes on its wings, and common brimstone looks like its surroundings. As for birds, I can see we don't have much time, but only to I will not be able to talk about each one of them, but something what is quite special, that common cuckoo is known as brood parasite. That means it lays eggs in someone else's nest. But what is also important, that it is able to show mimicry as well. The eggs seem like those eggs of hosts, and also the adult bird looks like a predator, like a sparrowhawk. The other one, more related to Arctic, is Arctic tern, which holds the record of travel, because during its lifetime it flies hundreds, thousands of kilometers from Arctic to the Antarctic, and it's the only known species that does that. Sometimes it's easier to hear a bird than to observe a bird. But, usually they're easier to be heard than seen because they hide. But also it is good to know where to find them. For example, cranes can be found in wetlands, but wagtails can be found even round lawns. They're close to human habitat. So now you're a part of a citizen science. You can discuss your results. You can not only make observations, compare your results. We encourage you to discuss your observations on our Edu forum. There is a special dedicated monitoring section. If you like, you can take photos for documentation, like I did yesterday. And in case of any problems, in case of any questions, please don't hesitate to ask us. For technical issues, as usual, there's support. And for any scientific issues, Institute of Geophysics. And for now, if we still have some time, let's prepare for a code quiz.
Okay, so we've got 6 questions. Where to put a thermometer outside the window at school or in the house? South side, it's red. East side, it's blue. West side, it's yellow. And north side, it's green. You need to choose only the color on your devices. The time's up, and we've got 18 answers, and 10 are correct. So good choices. And let's see the scoreboard. So we've got 5 the best scores shown. Okay, which cloud often forms thunderstorms? Cumulus humilis, it's red. Altostratus, blue. Cumulonimbus, yellow. And cirrus fibratus, it's green. Time's up. We've got 21 answers and 9 are correct. So also the best score is for the correct answer. And let's see the scoreboard if anything changed here. We've got Anastasia on the first position, but we've got still 4 questions to go. Which phenomenon restricts visibility to between 1 to 10 kilometers? Aurora borealis, it's red. Mist, it's blue. Hoar-frost, yellow. And fog, green. Five seconds to go. And mist is correct answer. We've got 10 good answers. So again, the biggest number here. And whoa, what happened here? Overrun is streaking ahead with 3 in a row. Okay, so congratulations. And number 4, which of the following pairs are correct? None, it's red. Cuckoo and mimicry, it's blue. Answers 1 and 2 are correct. Ha, it's not that easy. Or bumblebee, thermoregulation, it's green. It was quite tricky because the Kahoot is mixing answers, so it was not easy to find this 1 and 2 which are correct. But obviously blue and green were correct, so all that voting for blue, green, and also for yellow, which were the best answer, were right. So let's see. Anastasia is on the first position, so probably very stable on that, but we will see. Arctic terns are famous for the longest migration routes, it's red, being the largest marine birds in northern hemisphere, it's blue, being brood parasites, it's yellow, or being the only birds breeding in the Arctic, it's green. Eight seconds to go. So the longest migration route is the correct answer. I think this biological part was quite difficult. Let's see what happened. But for those who are really listening carefully, we've got still Anastasia on the first position. And the last question is, the 3 main non-biological factors that affect phenology are sunlight, wind force, acidity, it's red, precipitation, temperature, sunlight, it's blue, humidity, wind force, acidity, yellow, and precipitation, wind force, temperature is green. Five seconds to go. Precipitation, temperature, and sunlight, those 3 are the main important factors, non-biological factors. And let's see what we've got. So in fact, the winners got all 3 of them, have 3 good answers out of 6, but still they were the best in today's game. So thank you very much for the game. And we are coming back to Ania, and she will present how to provide observations at the portal. Aniu, nie słyszymy Cię.
We're back.
Okay.
So as for movies with birds, we'll send them to you via email because somehow they did not upload. But let's get back to those measurements. Here we are on our portal and we're already registered and signed in. We go to program and then monitoring. And this is what we see, a monitoring system and a map which displays results of our measurements. And some, maybe not all, but some examples of measurements. As for actual values on Monday, here we have our air temperature is 6 degrees plus, of course, luckily. And As for cloud cover, we're looking through our window. We have a complete cloud cover. That means we see no sun. For now, there is no precipitation, even though there were showers before, but we were talking about actual values for now. So, as a result, we cannot choose types of precipitation. And as for visibility reduction, I think we have a miss. Wind force. I cannot see branches of trees moving at all, so we're choosing no wind. And here, since the last observations, maybe we exceeded time, but maybe, for example, some biotic field observations. Like yesterday, here for monitoring plants, we have to indicate species which opened buds since last observations. Actually, I did not observe any of that, so I'm not marking anything. But what we have to choose is we choose between birch, lilac, and rowan when they finally open and opened buds appear. And as for species starting to flower, for now it's nothing yet, but we choose also between birch, lilac, rowan, bilberry, also known as blueberry, and rosebay willow herb when their time comes. And the same, and that is a set of data, a set of parameters for plants, which is rather developed. As for animals, as for insects and migrating birds, it's much easier because we mark only the first observation in the year. That means we only mark every species only once. For example, if I saw a bumblebee, which did not happen since last week, I would mark it here. And I know that especially in Southern Europe, we already have observations, for example, of an ant. And for migrating birds, we also choose the one that appeared since last observations. Like I said, for now, at least in our surrounding, it did not happen. We haven't filled every gap because we're a little bit short of time, but and we're trying to make it absolutely real, as you see. But after finishing this, and actually we'll close to 12, and with the temperature will be correct, we would press submit. Also, you can always press cancel to come back to the previous view. So I'll stop sharing my screen. This is it for technicalities of observations. As you can see, it's quite intuitive. And it doesn't take much time. What might take a little bit of time is an observation in the field itself, especially for particular plants and animals, but we hope it is a pleasure too. So like I said, we'll send you those videos or links via email. And I think if there are any questions, please feel free to ask them. Or maybe if you don't have time now, you can also use EduForum, for example, or the email.